Excuse me. So let's get rolling here with what are called nth roots, rational exponents. I think at some point in time during first semester, I might have shown you guys what was called an nth root at one point, just to, and maybe just brief conversation explaining where the term came from. As we got into it, we didn't really spend a ton of time on it. We talked about square roots, what a square root actually meant as far as what the exponent of a square root was. You guys remember that?
Yeah.
Vaguely? Yeah. What was the exponent for a square root? Do you remember? That's squared. Half. Good, it was half. Square roots were 1/2 powers, and that's where the idea of a fractional, where these fractional exponents come into play here. That's why they're called rational exponents, because rationals are generally considered fraction sum. As you recall, towards the end of the second semester, we had all those rational expressions where we had to simplify, cross-multiply, common denominators, factor, all that kind of fun stuff. This is kind of along the same lines with a lot less factoring, if that makes any sense. There's still factoring second semester, probably not as much as was first semester. That was kind of a first semester big thing. Second semester kind of goes through a bunch of this. What this stands for, do you guys know what that's called? The fourth root. Yeah, it's called the fourth root. And when you say fourth root, when you think about it in terms of a fraction, fourth is 1/4, right? That means this is the exact same thing as 81 to the 1/4 power. 1/4 power, if I can write. Okay. That's where that comes from, the idea of what's called an nth root. When you had a square root, the value that's up in front here, if I just wrote the square root of 81, that would have been written as the imaginary value that you don't see there would have been a 2. Does that make sense? So we just don't write that. It's kind of like the same idea wherever you have an exponent. If you just have x, what's its power? 1. You just don't write it, okay? It's kind of the same basic idea. What's the coefficient in front of the x here? Again, you just don't write it. It's kind of like one of those things that you just don't have to worry about. So this is the exact same thing also as 81 to the 1/2 power. That's where this idea of what are called nth roots come into play. Okay? Excuse me. So what happens here is this means what are 4 numbers that you multiply together that are the same to get you to 81? Well, that's pretty easy. What are they? 3, 4, 4, 4, 4, 1. Negative. Remember, it's you get there eventually, right? So the idea is same idea. Same thing goes for when you have an even nth root. It's always going to be plus or minus. Okay. Even nth roots will always be plus or minus, whereas odd nth roots, that's the idea of. Well, we did this also. Well, let's clean it. If we did the cube root of 8, what's a cube root of 8? 2, okay? So what would be the cube root of -8? -2. It would be -2. The reason that it's negative is that you can take a negative nth root of an odd. Sorry, you can take an nth root of something that's negative if the nth root is odd. Does that make sense? That's the odd value is where it comes into play. Okay, so if it's odd nth root, you can take you don't have to worry about imaginaries. All right. Textbooks, in this case, we don't really see any imaginaries with any of this stuff. To be honest with you, so you have to really worry about that. It's either going to be plus or minus because it's an even nth root, or it's going to be whatever the value is underneath the radical for an odd exponent. Does that make sense? Or odd nth root, excuse me. Get my exponents mixed up. Now, also go with this, excuse me, that's where this all comes into play. You get, this means the 125, what would be the cube root of -125? 5. Now, all these values are going to be stuff you'll be able to figure out without too much of a hassle. Okay. Same thing here, the 4th root of 16 would be what? Plus or minus 2. And this also goes to show remember when we did solving of equations, whenever you took a square root over an equation, what did you have to do? plus or minus stuff. So you did your plus minuses as well. So that's where all this comes back into play. All right. This is nothing that's going to be horribly scary bad today, I hope. Until you get to this. So disregard the rules here for a second. Okay, disregard the rules for a second. And what I want you guys to remember is a minute ago we talked about anything to the 1/2 power means what? Square root, okay? So that means this is the square root of 9, but now the exponent in the numerator means you do what to that? You cube it. The denominator is the nth root. The numerator is what you do to it after you're done. Okay? So you cube the square root of 9. What's the square root of 9? 3. What's 3 cubed? What is that? What this means is the denominator is the nth root, and then order of operations tells you to cube it. The nth root is the denominator. The numerator is what you cube, whatever you do to that exponent, that power, when you're done with that. Okay. And then, like I said, you just go through your order of operations and you work on the innermost parenthesis stuff first and work your way out. So again, the square root of 9 was 3. Then you cube it, and you get 27. Now, when you get to, and I'm glad you said that. When you get to things like this, you're going to keep it with whatever the value is. Okay. So in this first one, it says 9. So you say it is positive. If you look at the last one, see how it says the cube root of -8 to the 5th? Then you take care of the negative. Okay? This is the one you stick with what it is literally. You more or less the plus minus ones will come in when we do equations. Okay? What happens when you have a negative exponent? You guys remember? You move it where? Well, is this one in the basement or is this one in the attic right now? Okay. See how I came off that one right off my head? It's upstairs, not downstairs. Oh. Yeah, I'm sorry that it comes first. Sorry, he's like son. You didn't even notice he's someone's new. You're shunning him already? No, we're not shunning. Anyway, so what this means is you want to make sure you make it happy. Okay? You want to make sure you make it happy right off the bat. And you just have to move that whole, since it's a negative exponent, everything gets moved to the denominator in this case. Remember, if it's negative in the denominator, you would move it up. So all those exponent rules still apply. We'll just get into a lot more of the weirdness of them with the fractions over the course of the next few days. So this means what is the 5th root of 32, and then you square it. What are 5 numbers that you multiply together to get 32? 2. So this means this gives you 1/2 squared, otherwise known as 1/4. Okay. You'll be able to tell these roots rather quickly as you go through it. If you have 5 numbers that you're multiplying together to get you something that's like 32, the only number that it's going to wind up being is going to be 2. Because automatically you think of it as a 3. 3 squared is 9, 3 cubed is 27, and 3 to the 4th is, 3 squared, which is 81. So it gets big really, really fast. Yes, ma'am? Remember, it just means it wasn't happy. Remember, whenever you have negative exponents, you want to flip it from the top to the bottom or bottom to the top. Okay? Just changing, making them happy to be wherever they need to be. Okay? And then last one that we had on here was what, the cube root of -8 to the 5th. Well, what's the cube root of -8? -2, and then, gee, what's -2 to the 5th? Oh, I'm sorry. 100? No. What was the 5th root of 32? 2. So 2 to the 5th would be, but then we have to throw the negative in there, so it's going to be equal to -32. Okay, do it now, just don't do it later.
Actually, all I did
Don't BS us. We know better.
Actually, I looked up my the guy who was like reviewing like all the finals
Nerd. All right, let's rewrite this. Let's rewrite this as an exponent. What would that be as an exponent? 5 to the 3/4. Good. Remember, the nth root is the denominator. Whatever it's being raised to is the numerator. So the nth root is the denominator, so it's 5 to the 4 3/4. Okay, that's what that means. Okay. Now, is that something that you could find? No. You really can't do the 4th root of 5, can you? No. But, oh, we just did the other one, all right? Same idea here. This would be, if I rewrote this one, this would be -8 to the 5/3. Again, we don't use mixed numbers. We continually use top-heavy fractions, and that's the idea of why this goes. I am kind of annoyed sometimes with the textbook. They use a little bit of slashy fraction, so just be careful when you see that. Make sure that you try to write it vertically. It does tend to keep things a little bit cleaner in the long run. Okay? Just so you guys remember that. So far, so good? All right, well, what do you think you're going to do when you start solving equations with these? Exactly. You do the exact same thing you guys have all done in the past. You work backwards. Okay? None of that changes. The only thing that's going to change here and there is some of the roots themselves. The nth roots might be a little bit weirder to find, but again, it's going to be stuff that you're going to be able to figure out without too much hassle. Okay? So 2x to the 4th equals 162. So what do you do first? Yeah, divide by 2. So what's half of 162? 1. Good. And then how do you undo a 4th? You have 4th root. Yeah, I see where you're going with that. You would take the 4th root of both sides. And the 4th root of something, should that be a plus or minus or a regular? It should be plus or minus. Very good. So what's the 4th root of 81? Plus or minus 3. Good. Again, I'm not going to give you values you're not going to be able to figure out off the top of your head, okay, without too much of a hassle. I really do try to make sure you guys see values that are easy to work with. Shouldn't be horrible, scary value. Okay? Excuse me. All right. Same deal here. The quantity x minus 2 cubed equals 10. Well, what do you do first? Cube root it. Good. You cube root both sides. When you cube root two sides, do you have to do a plus or minus? Good. Do we know what the cube root of 10 is? No. So what do you write? Cube root of 10. Okay. Now what do you do? Got 2. Good. So I think we might have seen something similar to this before. Whenever you have a weird root, put your constant in front of it. Okay? 2 plus cube root of 10. I think sometimes textbooks or the CUDA sheets kind of put it on the back side of it, but the tendency for people to do when you put those nth roots, you tend to make the radical sign too long, and it could cover up something. So just put it in front, you don't have to worry about it. Okay? It's kind of like when we did the quadratic form of this stuff. You put the opposite of b plus or minus the square root, you just kept all those values in front of the square root. Same idea. Okay? If you can stick with that, you'll be fine. Right. Terrible? Let's see if I can screw this up. And we did those. Oh, I know. Boy, that looks really scary. X to the 4th minus 3 equals 9,993.
And it's 10.
Make it 1,000, buddy.
Well, you have the 7. Or a $10. and then you get 10.
I should ask if you can break a 20 then. That required me having to have a 20. Okay. I don't either, so. Again. So even though it's 10,000, well, how many zeros are there? 4 of them. So if I take the square root of that, that means I'd have how many zeros left? 2. And I take the square root of that. So you get x would equal plus or minus. Whenever the exponent is even. Okay, whenever the exponent of the nth root, whenever you take the nth roots of even value, that's when you'll do plus minus. Okay? As you do a few of them, you're like, oh, that's all. Treat it like, just remember like your square root stuff wasn't even exponents, it was always plus minus. So anything that's even, 4th root, 6th root, 8th root, whatever, you just throw a plus minus and you're good to go. All right? Where was the weird ones? Okay? Do you remember how to do these? Oops. Oh, I know. Sorry, I had this here. Forgot this was here. What about this one? X plus 26 to the 3 halves equals 512.
Wow, that sounds fun.
Okay. Now, I want to see if you remember what to do with the exponent.
We're going to take square root of
Square root of 5.
square root of 5.
So let me ask you this. Hold on a second. Hold on. So when you went back and you did something, let's say that it was x squared is 9. What did you do? Square root, right? Square root is what power? 1/2, right? So if I took both powers to the 1/2, that means the same thing as taking the square root, doesn't it? What's the relationship between 2 and 1/2? Not opposite reciprocals, they're just reciprocals. Okay? They're just reciprocals of one another. When you multiply 2 times 1/2, what do you get? 1. Your exponent becomes 1. That's how you were undoing those things. So if you go back to something like this, I go back to something like this. Oops. If I go to this one, to both sides, I can't do the 3 halves, I have to do 2/3. Okay, I have to do 2/3. So now you undid the one side, you're going to get x plus 26 is 512. Oops, sorry. We rewrite this as the cube root of 512 squared. So without using the calculator, let's see if we can guess and check our way to figure it out. 512. Well, if you did 8, does it work? That's a good idea. I mean, I was going to say, I would guess, I know that it's not going to be 4, okay? Because 4 cubed is, well, what is that, 64? 16 times 4, so that's small. 5 cubed is 125. So you start thinking like, okay, it's got to be bigger than 5. 6 is probably still too small, so checking 8 isn't a bad idea, because what's 8 squared? That's 64. So I do 64, I multiply that by 8. Well, what's 8 times 4? Automatically you're ending in a 2. So it's a good check. You see how I'm doing that? So even though you don't have the calculator, you could kind of fudge your way through this. What's that? It's 48. Oh, look at that, 51. So what would be the cube root of 512? 8. What's 8 squared? 64. So x plus 26 is 64. Even though that value of that radical, or the number underneath it, is large, it's still feasible to figure it out without too much of a hassle. Okay? Subtract your 26. Oh, did I have to do plus minus or anything here? No, because of the cube root there. So subtract the 26, what do you get? What is that? 38? Is that right?
Yep.
Okay. That's the idea behind some of this. We'll get into more of that weirdness of those. Did we do those today? We have a couple of them today. Let's try another one of those. Where's the other one? Sorry about the line through the middle there. So, what exponent are you going to do on both sides? 2/3, okay? And did we just did 2/3 of 512, didn't we?
Yeah.
So, if you do the 2/3 of both sides, what was the 2/3 power of 512? What do you get? Okay. You'll start to see some of the same numbers pretty regularly through a lot of this, just because they don't want to. You don't want to get them to be too large and too crazy. You'll see 512. You'll see 216. You'll see stuff like that. Oops. Bless you. I should laugh, but
That was
really?
really, yeah. He was like writing on the motherboard, and then he like went over a bump. Like now, he like his arm like on his leg, like one of our dates, he like really bloody and gross. Hilarious.
Anyway, same idea here. So you have x minus 6 to the 5/3, quantity to the 5/3, equals 1024. Right? What do you have to do to undo the exponent? To the 3/5. So x minus 6 can equal, well, the 5th root. Well, let's see here. We know 2 to the 5th is 32. That's not. 3 to the 5th would be 81 times 3. That's not going to work. 4 to the 5th, well, that would be what? 4 squared is 16. 16 times 16 was 256. Is this all right? What's 256 times 4? Again, see where I'm going with this? You use values that you know how to square. Remember, when you square something, if I square something, that means the number of times you multiply it together, or any nth power, which means you can break this down into 16 times 16 times 4. You know, so that's 4 squared. 4 squared. Remember, you can break the exponents apart into the values themselves. It makes it a little bit easier to work with. Okay. All right. It's just a little like another idea of looking at it. So this one would have been the 5th root of 1024 was what again? 4. So you have x minus 6 equals 4 cubed, and 4 to the 3rd power was how much? 64. Add 6 and you get? Wait. I love when our plan goes together. All right. Let's see if we can get it. All right. Well, let's make it look really awesome. Whenever you see the negative values for the fractions, remember, try to float it to the top. It makes your life a little bit easier. Float that negative value to the numerator. Just the way that things work, that's how the typesetting goes. Sometimes they just put it right in front of the in front of the fraction marker. All right. So, excuse me. We have negative 191 over 32 is quantity x minus 8 to the negative 5/6 minus 6. So working backwards off of this, what would you have to move first? Work backwards. Add 6. Okay? So if I add 6, I need to get that as a denominator of 32. So that just means I have to multiply 32 times 6, because this is 6 over 1. Okay? That's not too bad when we get a 2, 192. Does that look normal now?
Yeah, pretty normal.
What's 192 minus 191? What would you have to do to the exponent to turn that into a 1? What's the reciprocal of negative 5/6? Negative 6/5. Okay. So now you do negative 6/5, negative 6/5. The exponent on the right, when you multiply that together, becomes 1. So you have x minus 8. On the left now, since the exponent isn't happy, now you flip it. Okay? When you flip this, excuse me, this becomes 32 to the 6/5. 6/5 means the 5th root of 32 to the 6th, correct? So, what's the 5th root of 32? 2. 2 to the 6th is x minus 8. Well, if 32 is 2 to the 5th, 2 to the 6th would just be multiplying 32 by 2. Well, what's 32 times 2? 64. 64. There you go. Even though it looked awful, it really wasn't bad. Okay? Even though you're still working with weird exponents, you're still getting common denominators. But obviously, in this case, the common denominator is pretty simple. All you do is multiply it by 32, get you moving. Okay? To be honest with you, if you start getting really, 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 really crappy values, you screw something up. Most of these should be relatively clean as we go through. Okay? Bring puntas. Questions? I thought you were in Spanish too. No español para su clase de español. Let's go those. The first set, those first 5 or 6 there, are basically like the cube root of 64 to the 5th. It's things like that where it's trying to get you to evaluate someone without using your calculator. Try to stay away from the calculator as much as you can with some of these because, like I said, more often than not, you won't be using them. I try to make sure that you guys get values that work pseudo-clean-ish. Plus, it'll help you when we get into fraction stuff tomorrow. A lot of adding, subtracting, multiplying, dividing. Common denominators again tomorrow, big time. And then we'll go from there. I think we'll get through all of that 7-2 tomorrow, and probably a little bit more of the equation stuff as well. And it should be good. Okay. PDF is already on there. I believe I shared it. I don't know. I tried to remember to do some stuff over break, and I just didn't do it. I thought I was going to. As in, I didn't do anything. It's good though. You know, you need a break.